Hi, yes, ma'am.
Yes, ma'am.
Okay, I'll start. Yeah. Good afternoon, all. Now, we would like to introduce our next speaker, Dr. Vijaya Laxmi. Dr. Vijaya Laxmi has done her MSc in Environmental Chemistry and PhD in Environmental Science and Technology from JNTU, Hyderabad. Currently, she is the chairperson for the Board of Studies in Environmental Science and Technology. She is also a member of State Level Expert Appraisal Committee for Telangana and member in Executive Council JNTU Hyderabad. Today, ma'am will be presenting on the topic Spatial Urban Planning and Land Management using Geospatial Technologies. We now request Dr. Vijaya Lakshmi ma'am to address the session. Welcome, ma'am.
Yeah, thank you very much. Good afternoon, good morning, and good afternoon to all. Hope all of you are keeping safe and staying fit. And I thank the organizers, especially the SVCA, for giving me this opportunity to talk to you on virtual platform. Hope I'm audible to everybody.
Yes, ma'am.
Yeah, thank you. So the topic like which we will be discussing for the next couple of minutes is on spatial urban planning and land management using geospatial technologies. Most of my talk for the next couple of minutes, I'll be concentrating, or rather, I'll give you a feel of the technology where, as an architecture or urban MURP students or the faculty, like I would think most of the participants are faculty. So, how best you can infuse the technology uh, to the curriculum, in the curriculum, or by way of guiding your own students and giving them the projects in the area of this particular subject, geospatial technologies. So I request the organizer to share the screen, or shall I go with the sharing of my screen?
Hi, yes, ma'am.
Yeah,
I,
I'll do the screen sharing. Yeah, just a minute, I'll just share. Hope all of you are able to see the screen.
yes, ma'am. We can see the screen.
Yeah. So I'll be concentrating on the technologies, geospatial technologies, how best they can be employed in urban planning and land management, and referencing to the spatial way of decision making, right? So the spatial urban planning, the term itself denotes like you are going to plan a urban area, or for that matter land use and land cover, how best it can be planned and developed, and in a manner like sustainable growth, right? So we'll be just seeing like the need for urban planning, like, so the most important aspect is the urbanization scenarios, the population migration, right from your rural areas to the urban, and how the urbanization is increasing, as you see in the world or as a global, and in India, global and national scenarios, you can just see. So on an average, like we are seeing a growth of urban population around 4% last decade when you see, right? And the urbanization or urban populations trend also you can see on the screen, like half the decades, like right from 50 to 60 onwards to the present, and the projections also like 20, 40, and 50, how the urban population is going to increase. So in India, degree of urbanization from 2009 to 19, if you see, the trend shows an increase of urbanization by almost 4% in the last decade, meaning people have moved away from rural areas. The factors which contribute for moving from rural to the urban, as we know, it is not just their change in land use or because of the natural factors also, because of the famines, because of the drought, because of the meteorological conditions and rainfall shortage or the precipitation. In addition, looking for better livelihood opportunities, looking for better employment scenarios, looking for better amenities, right? So these are the factors which contribute, or rather, which encourage the people to move from the rural to urban areas. And when you have the trend changing, you will also have impacts because we are not having a sustainable or a balanced growth. So what will be the impacts? Like if you see the impacts, the infrastructure, demand on environmental resources, water supply, transport, linking infrastructure, the connectivity aspects, and amenities and others. And this involves change in economic, social, and political structure of a region. So when you have a migration or a movement of population from rural to urban. So all these things, like you can envisage, right? The changes in economic, social, and political structure of a region. So that is a need, like urban planning, where it demands like urbanization and its associated problems, solutions, and way forward. So when we see urbanization, it is not just only the associated problems. You can also, if you address strategically how best you can incorporate the solutions in decision making process, you can have a sustainable urban growth corridor also, right? So we'll just see the increase people living in urban areas has grown, the urban population has grown, and the proportion of people living in urban areas has increased. It may lead to the uncontrolled settlement of low income families in squatter areas. So the increase in squatter settlements or slum areas, that will certainly will have growth. And housing is a basic human right, but without effective control, it may harm the ecological balance, living standards, or environmental balance. So the emphasis need to be on land use planning, management, and development in view of your urbanization and migration of rural population to urban areas. So you can just see the urban sprawl and spatial patterns of development. Once if you see how the urban sprawl, like if you think like in urban areas, the when we see basically the land use and the land cover, I'm sure the participants are aware of the definitions of land use and land cover. So the land cover is nothing but the natural existence, like with minimum of what to say, the built up area or the settlements, the natural vegetation, the water bodies, geology, or whatever. And the land cover is not, sorry, the land use is nothing but the land put to use by human or the anthropogenic activity. So the land use predominantly says the particular land has been categorically put to use by humans for a particular sector or a particular activity, like industry, the commercial, the recreational or horticultural, so the agriculture, etc. Or for that matter, geological also, mining, right? So the urban sprawl, when you see, it has to be in a uniform manner. Like the urban sprawl should not give any pressures or thrust on the environmental resources in that particular area, right? So how the spatial patterns of development are taking up or taking place, and how you can project it in future also, that can be discussed. Like I'll be showing next couple of minutes. I have around 91 slides, don't worry. I'll just go through only the case studies which our departments and our project students have done all these works. So it will be a added flavor to architectural students and the faculty, how best you can take back after the webinar, how best you can incorporate the technology,
Ma'am,
right?
I had amazing lecture and good presentation. This session was very informative for giving us knowledge to understand spatial urban planning and
Uh,
architecture.
s-
Ma'am, Ma'am, we thank you for the overview of geospatial
Some
technologies.
disturbance, I'm getting cross recording. Yeah. So the next is like the competition for land is increasing as demand for multiple land use and ecosystem services rises. So urban resources and environmental problems that foresee are pollution. The first and the foremost, we all have experienced and rather experiencing and all this, right? So urban resources and environmental problems, you have to name pollution as air, water, noise, and municipal solid waste, especially in urban areas. That's a big problem. And reduction in vegetation, when you see the green cover in any of the urban areas, as per the policy, as per the MOEF, Ministry of Environment Forests guidelines, in any of the area or in any state level or a district level, whatever, 33% of the land should be under vegetation. So that is a policy the government of India gives us. So whether we are meeting that reduction. So obviously, when you have urban migration, urban sprawl, the growth and all that, there will be certainly a reduction in vegetation. But how best you are going to cope up? And the next one is urban heat islands. The hotspots are the heat island on the radiation and the pavement, concretization, the concrete jungles we call it. So that all attributes and contributes to the urban heat island. Then impact on surrounding areas. What will be the impact on with reference to the social structure, with reference to the economic structure? Then importation of food, energy, and other materials. So the urban sustainability, the livelihood, and you need to import food. Actually, see, none of us grow vegetables in urban areas, so we have to depend on the periphery or fringe areas or rural areas, like, right. So you are importing your food, energy, and other materials. So these are the issues in going towards urban management. Then spatial and land use planning can contribute to sustainable land management. So how best the spatial and land use planning, right? So that will give a sustainable land management approach or a practice. So you can just see on the screen the land use planning, where the spatial land use planning is a subset of it. So you are trying to uh, plan, you are trying to take a measure with reference to all these aspects of ecosystem based land use planning, green corridors, lung spaces, you call it. Then all the ecosystem based services like commercial plantations or livelihood, how best you can improve the livelihood based on the ecosystem services. Then regional land use planning, integrated land use planning, territorial ecological planning, urban land use planning, spatial land use planning, participatory land use planning. So these are all the subsets of your land use planning, right? So spatial planning is linked to the economic development and facilitates infrastructure planning, especially transportation planning, to determine land use in managing urban regions. I'm sure this will clearly define the objective of my talk for the next few minutes, where I'll be showing you the case studies which we have done, which we have carried out. One project is funded by Department of Science and Technology, and the other by our own master students. So I don't know how many of you are well versed with the terminology geospatial technology. uh, Basically, when you talk about geospatial technology, what exactly this means, like, so I don't know how many of you have read the technologies like remote sensing, GIS, geographical information system, global positioning system, and nowadays we are all talking about UAV and drone technology, right? So GST, we call it as a geospatial technology, as a planning tool and decision making support system. So the GST, geospatial technology, broadly has got remote sensing, the contributing disciplines we call it, or the contributing technologies as remote sensing, geographical information system, You can see the global positioning system and other emerging technologies, as I said, like you have your positional and EDMs, electronic distance measurements, your handle global positioning system, GPS, handle GPS systems, you have to get the coordinates or the positional information, right? Your geographical coordinates will be captured or rather mapped or whatever using these technologies, right? Other emerging technologies, we have UAV as one of the upcoming technology, especially used in agriculture and urban areas. And then we have drones, the other one also. So the geographic, spatially referenced or georeferenced, these are all the synonyms. So data are alternative terms for geospatial data. So when I use in my lecture, like sometimes I may be going with geographic data or spatially referenced or georeferenced. These are all the synonyms you have, we use in the geospatial technology. So let's focus about remote sensing. I just give an understanding, brief overview, how the technology is able to guide us in preparation of land use and land development plans. So remote sensing as a faculty of the webinar, I'm sure it makes you inquisitive to know how you are getting the data when I say land use land cover map from a satellite imagery. So the concept of satellite remote sensing, you can just see on the left side of the view graph, satellites in orbit are in position rotating around in its own orbit around the Earth, right? So the satellite is capable of recording the information that is reflected by the objects on the Earth's surface, right? So you can see universal source of energy is our sun. So from the sun, we have electromagnetic radiation falling on the Earth's surface in different bands, like right from your cosmic rays to radio and television waves. In between, if you remember your basics of your physics and all, we have studied Vijaya, visible spectrum, infrared, microwave, and etc. Right? I'll not go much into the physics, but the basic concept here is every object, whether it's a living or a non-living, has a capacity to absorb, capacity to transmit, capacity to reflect the energy, or in terms of electromagnetic radiation falling on the surface, right? So as a concept, I mean, in the satellite remote sensing, the basic objective is we will be taking the reflected portion of the spectrum sensed by your, just a minute, please. Actually, we have an urgent call, that is the reason. Kindly bear, excuse me. Sorry for the inconvenience. Yeah. So whatever the reflected portion of the energy we have, that is captured by the satellite and subsequent sensor. Satellite, just imagine all of you have used your cameras, right? Now we have all the digital cameras with a memory card or a memory chip. Earlier we have used Nikon film or what to say, the Kodak or a Konica film. If you remember, a black and white roll or a color roll we have taken up. So your camera is nothing but your satellite, and the roll or the Kodak or the film, whatever we used to keep, that is as a sensor, right? So the satellite is the carrier, and sensor is nothing but a recording device, right? So the recording device has got its own capabilities, limitations, and its own capacity, right? So the limitations and the capacity, or in terms of sensor parameters, makes us to define which sensor can be used for forest, can be used for the water, grass or bare soil or whatever, depending upon its own parameters, right? So if you see the right side of the screen in the view graph, so you can just see the wavelength in terms of your right from your green or blue or whatever the radiation we have given in terms of wavelength, how the earth is sensed, right? So the concept of satellite remote sensing is this. So once the radiation falls, the scattered radiation or a transmitted radiation or absorbed radiation is not of interest to us. Only the reflected portion of energy by the object, whether it's a road or a concrete or whatever, is of interest to us, right? I hope I'm clear to you. So this is the overall complete remote sensing system addressing the societal concerns. So you can just see number of applications right from your health, disasters, forecasts, energy, water, climate, agriculture, ecology, oceans. Right? You have different platforms, we call it space-based, air-based, cryosphere-based, land-based, and ocean-based. Right? Yeah, these are the platforms we call it. So aerial remote sensing, you can just see the aerial photography. You can see the multispectral satellites, we call it, uh, based on the high altitude. Then radars and microwave you can see, and the hyperspectrals you can just see. So this is what the parameters which define us. I'll just run through the spatial resolution. You can just see on the image to the left side, 180 meter. I said resolution, that is 180 meters. One has 5 meters, one has 24 meters. So I am sure you are able to see the image. Are you able to see clearly?
Yes, ma'am. Ma'am, can you make the screen full lights?
Okay. Yeah. Is it okay?
Yes, ma'am. Thank you.
Yeah. So if you can just see the difference, one is talking about 180 meters, one we are talking about 5 meters, and one we are talking about 24 meters. So that defines the capability of sensor, 24 meters or 5 meter, or at the most, like right now we have 0.5 meter also. So you just see the middle of the this one, the sense imagery. You can just see 5 meter. That means every 5 meters you can map, right? From the starting 0 to next 5 meters, next 10 meters, next 15 meters. Like that, you will get the data. Whereas in the 24 meters, you will get the data within a resolution of 24 meters, 0 to 24, then 24 to 48, right? So like that, you can identify different features on the Earth surface, intervaled at the specifications which I have mentioned. Whereas in the left most, you can see 180 meters, right? After 180 meters, approximately 200 meters only, I can identify the feature, what is present, what is not present, right? So this is, you can just see the 30-meter resolution, 100-meter resolution, right? 5-meter resolution. Half for the urban areas, you can just see the blue areas, you can just see, or you can interpret as a water body, the green as a vegetation, or in urban areas. And the other polygons, we call it, other boxes, if you just see they're all polygons, we call it as a settlement or whatever, right? The spectral resolution, I'll just give the parameters. Like, see, in the first slide I said reflected portion of the energy, I said from a surface. So the reflected portion of the energy can be either in the blue green red spectrum, or at intervals of this, or a combination of multispectral, right from your blue green to infrared also. So that resolving power of the sensor in one spectrum or one band talks about the spectral resolution. So spectral resolution, if it is only one band, we call it a black and white image only you can see, right? So if you just see the spectrum in different color codes or in different color bands, you can just generate a color imagery also, or a color photograph. So this is the intensity levels which talks about the sensor's capability. I'll just skip. And temporal resolution, like See, in the first slide, you have seen a sensor is centered. I mean, satellite is rotating about the around the Earth's surface. So to make one revolution, one come back to the other same position. Like today, satellite is passing at 10:20 a.m. over Hyderabad, right? After completing one revolution, after how many days? Is it 2 day or a 16 days or 20 days or whatever? It is going to come back to same Hyderabad, right? So why I'm telling you this is in any urban planning, urban areas are very dynamic in nature. Tomorrow you may see a land parcel vacant, which was yesterday, right? A building or a construction activity may come in. So a few months or years back, you must have seen an open nala, you must have seen a drainage channel uh, passing through that particular area. After few months, you may not see the same channel. Like some encroachment may come across, some encroachment might have taken up, isn't it? So to monitor such kind of dynamic activities, you need to understand the sensor capability. Every fifth day you want to monitor, or every 20 days you want to monitor. So that kind of the facility we have in the technology, right? So these are all the Indian remote sensing systems. Like morning, I was attending a one particular important talk also on space areas. So these are the facilities or the our own capabilities Indian remote sensing system we have, depending on few hundred kilometers of resolution to 2 meter resolution. We have our own capability, and on par with any of the developed nation, uh, India stood on par with all the developed nations, in, especially in space science, space technology. So these are all the applications you can mention, like agriculture, water resources, forestry, and all urban studies, which we will be discussing in detail. Yeah. So I said like geospatial technology. So the database or the source of data is from remote sensing. How do we get the geographical features like? So that is the sources from remote sensing data. So how we are going to take that data for any kind of decision support system, right? So where we have this GIS, which stands for Geographic Information System, and also sometimes we call it as a science, right? So you can just see the input where we take all the maps or the say the imageries or your own field survey data in terms of latitude, longitude, right? That forms as a geographical data or earth surface data or a positional data. And the information, like what you can attribute to that particular area. Say for example, you have a road junction, like a traffic junction you can have. What information you can add to it? Is it a highway? Is it a national highway, or is it a linking road, or is it a radial road, or it is under the state government or a development or the PWD or whatever R&D? So that kind of attribute information, and whether it's a CC road, right? Whether it's a track, mud track, or some kind of information if you see something. So that kind of information you will be adding to it. And the system, that is nothing but the hardware and the software which we employ in GIS, right? So you can just see on here the layers of information we are doing it. So one, you can just say in the planning process, you can have a road network, you can have a traffic, or you can have some built up land or a commercial establishments and all, and how all these three are interconnected. If I have a, see, basically if you see the high-tech city area or the Madhapur or Sherilingampalli or whatever the in and around the example I am giving Hyderabad. So if you see, if there is no connectivity, if there is no metro rail, or if there is no, see, we have metro rail connecting Uppal to high-tech city, right? So the accessibility, like, so how we are going to establish that you can have in GIS, right? So you can just see as the input and the analysis part is taking and the output, right? So it's a computer based system for the collection. These are all the traditional bookish book definitions you get. Otherwise, you can just say GIS nothing but collection, storage, and organization, maintenance, and analysis of spatially referenced data. The important aspect is you are referencing something as a spatially, like you are giving coordinates, you are giving latitude and longitude, and the output of spatially referenced information. So data you'll have any collection of related facts, the basic elements of information you'll have. Charminar, if you have Charminar, I can interpret by seeing a map or a Google imagery. But who had constructed, when it was constructed, where exactly, what exactly, right? So that kind of information, heritage structures, like if you want to see the heritage buildings in Hyderabad, in and around Hyderabad, so you can map individual buildings, but attribute data we call it, the data which you attribute to that particular building. Charminar you might see, but who had constructed, we don't know. When it was constructed, the image or the map doesn't give you that, right? So that kind of information you can link to that using your hardware and the software part. So you can just see the kinds of GIS you have, desktop applications you can have, then web mapping, web browser with GIS tools also you can have, and the apps and all. The very best example you can visualize is your own Arogya Setu app. I'm sure most of you in this pandemic, and we are all forced, or rather advised to develop, download that particular Arogya Setu app, where whenever you move to a certain place, like if I move from my home to JNTU, then it will ping me like you are in the proximity of COVID patients, or the whatever 20 people or 30 people, something, some kind of alerts it is giving us. So that kind of dynamic apps also you can use it. Right, the components of GIS is, this is what we have, the software, the data approaches, and all this. How we are going to do the approach part. Right? The two main types of data we do is spatial data, as I was mentioning you. Anything on the earth surface, whether it's a mine, whether it's a agriculture, whether it's a forestry, you name anything, right, that is present on the earth surface, that can be taken as a map or as a imagery, right? And the attribute data helpful to conceptualize as tables or metadata, right? Your solid waste you can see on the imagery, on the view graph, like this is what the land exactly looks like. So you have a geological, geomorphological features, you have the sand typology of the sand, you have buildings, you have infrastructure, industry, parks, and all that you can see. So all this information you can get from imagery or you can get from map. So that we are taking into the GIS system as parcels, we call it, in terms of you can represent the same data district wise, state wise, or what to say, the ward wise, right from your micro level planning. You can have all these things can be viewed in geospatial aspects or the domain, right? So GI software tools, you have number of software tools. Generally, the initially it was developed in Harvard, Yale, Minnesota, Clark University, and the primary softwares we have ESRI. These are all the commercial softwares you can have, and the open source software you have is QGIS right now, right? So this is how the database looks like. When I said like geospatial data, see, you must have seen Oracle also, any of the ERP softwares also you must have seen. There we are not, the database looks like the similar, right? But there is no spatial aspect into it. So the advantage of GIS here is you are going to link the spatial aspects, that is nothing but the earth surface or the geographical features or georeference data, right? So that is linked to the database. So you can just see how the database is linked to this. So you different type of database systems we have, data models we have in GIS, we call as generally raster data, vector data, And we also talk about simple file structuring, index file structuring, RDBMS, relational database. So the power of GIS is the interaction between the database and the map, along with the ability to create graphs, tables, and reports. So you can just see one of the example here also. So this is the power like decision support system. So how does the GIS answer spatial questions? So it can have your input data, edit both spatial and attribute data. You can edit at any time. Display data on screen or print a map. Analyze the data for making decisions and searching for patterns. Create models and ask what if. What happens? See, for example, just you can visualize this as your land feature, right? If you think this is your industrial area, or this as an industrial zone, or this as a residential. So the basic essence of the technology should be able to guide you when you visualize this particular earth, and when you go for planning aspects in terms of zoning, like especially. So that can be taken like if you have a slope in this aspect, slope is towards this direction or slope is in the other direction. So whether you need to have a industry, whether you need to have a residential setup or a, area developmental plans or a town and area development we call it. So that kind of aspects the GIS should be able to give you, right? So what kind of types of questions can be answered? Where are the particular features found? What geographic patterns exist? Where have changes occurred over a specified time period? Where do certain conditions apply? And what will be the implications if an organization takes a certain action? Right? So these are all the questions you can be asked. So particular features found, geographic pattern exists, and changes occurred over a specified time. If you just see, you have all the red building blocks here, some houses you have, and if any one particular house or two individual blocks have taken away and a big commercial mall or something comes up, or as a vertical rise like in cities we are seeing like individual houses also they are demolishing and going with a 5-story building or whatever the land permits depending upon the municipal approvals. So what is the impact of that particular activity on the nearby resources in terms of water availability, surface water conditions, groundwater, etc. That can be seen like what changes has occurred over a specified time like. So you can have just to infuse with a thought, the conversion of the land, entire Cyberabad area, high-tech city area, way back if you see 90s, early 90s or late 80s, if you see, if you think, I mean, if you happen to visit that, completely stony waste and boulders were there in that particular Madhapur high-tech city area. Hardly you can see any of the multi-level buildings. Now we have made it into a flat terrain. We have removed all the boulders or whatever the peak and valley, not the valley, boulders you have, stony waste, rocky, hilly terrain. We have disturbed that particular terrain feature and we made it flat and we have come out with a vertical rise 20-story building or a 20, 30, whatever, like if you see that particular Nanak Ramguda and all those areas, right? So what will be the impact over a specified time, like after 10 years, will there be any depletion of groundwater resource, how the penetration, etc. So those things can also be answered using the geospatial technology. So this is all the types of data are used and all. So this is the brief introduction, like what GIS, what remote sensing can do for land use planning, sustainable land use management, urban planning, and all. So now I'll go with the applications. Probably this will be more interesting to you rather than the theory which I've addressed for a couple of minutes. So the case studies, like one is space-based information support for decentralized planning. You can just see on the screen whether you are going to address from the local top-down approach or you can see or the bottom-up approach you can have. locals, district, state level you want to have, or state, district level, local you need to have. So depending upon it, you can define your data sets, remote sensing data, how we are getting the source of maps, resource map generation, then your GIS integration, how we are going to stakeholders to whom we are all building the town planning department or sanitation, the sewer network, metro water works, whatever we have, whatever supply division, power and electricity. These are all the urban areas which demand the resources that are demanded by the urban people. Like, so integrated, how we are going to get. Let's go for this spatial information. This is geospatial layers using satellite imagery. So I'm sure you all must have studied the scale and the maps which we have, like on 1 is to 10,000 scale. All the drawings which you do are architectural maps, they are to a scale, I know. And the maps which you have, land maps, land use maps, or the terrain maps, we call as cadastral maps, if you have heard about. Then the cadastral or the revenue maps, you will have thematic maps, you have soil map, etc. So the geospatial layers using satellite imagery, we'll go with on 1 is to 10,000 scale on a, as we call it as a small scale, sorry, the large scale map, large scale mapping. And for any of the urban areas, like generally we prefer to go with 1 is to 2,000 to 5,000, so that you will have better scale ratios. So the next one is the spatial layers from tabular stakeholder departments, data and census data you will be taking, and georeferencing of facilities, infrastructure, etc. So you can just see now I'm just telling you the latest, sorry, the latest technology we have, UAV and drone technology, where you can generate a 3D maps also. So urban studies, like I was telling you, green city ratings, land consumption versus land use, uh, along with the population growth, building information and energy demands, village information, slum information. So these are the areas like where we can give an idea. I'm sure you must have studied or referred about IGBC, Indian Green Building Council, and individual buildings are rated against silver, gold, platinum, platinum plus, something like. And the cities also, the towns or the cities or whatever, are being rated by this particular independent council, IGBC, Indian Green Building Council, right? Uh, Rating system based on, again, the green cities, the gold or the silver or the platinum, they do rate by whether the city master plan or the city planners have met the criteria in terms of green aspects, right? Green aspects not alone talks about the vegetation, but also in terms of water, energy, land-based, green cover, etc. All the things. So in any of the development, sorry, the rating system, the IGBC considers around 18 to 22 parameters, if I am correct. So out of which directly 14 to 15 parameters can be extracted from remote sensing data. That is the essence. So one of our student has done for the Serlingampalli area, so where the green building, green city ratings have been studied. So the tangible benefits of green cities are given here, like reduction in power demand due to higher share of solar, thermal, solar photovoltaic and wind energy, 25 to 30% reduction in the lighting consumption of city, then 15 to 20% reduction in water consumption due to better metering, monitoring, and reuse and recycling aspects also. Then increased segregation in municipal waste, leading to better handling and disposal facilities, and increase in use of public transport to the extent of 8 to 10%. So the connectivity, a city is rated based on its connectivity also, accessibility. Then 8 to 10% increase in use of treated wastewater for city applications. Intangible benefits, better land use, preparedness for climate disasters, increase in groundwater table. But if you have better rainwater harvesting, if your stormwater drain and if your sewer network is well in place, then your groundwater depletion will not, or rather may not take place. Right? Increase in the city landscape cover, provision for more public conveniences, citizen engagement through the city e-portals and better parking. So areas where RS, remote sensing, GIS or geospatial, so these are all the areas where we can directly intervene the technology in assessing this. So how the city landscape is there, is existing, whether the city's water bodies and the tree cover are well preserved, whether city soil also well preserved or not. So this kind of all these 16 parameters you can just address using the technology, encouraging the use of public transport, the connectivity, right? This is what you have. So you can just see the study area and the data used. We have used satellite imagery of the Cyberabad area, right? We have developed a digital elevation model, we call it, and you can just see here. I'll just zoom. Sorry. Yeah, you can just see here the Cyberabad area, Gachibowli. You can just see on the screen. You have all the individual building blocks have been mapped, right, from the imagery. So you can just see here the type of attribute data. Earlier I was mentioning this you can get from any of the maps, any of the imagery. But this information by field survey or by data sharing, whatever, so you can link that data. If I click on any of the polygon, we call it this boundaries or whatever the area we mentioned, if I click on this particular building or a polygon, the attribute information should be able to come here, right? Number of floors or ownership or the shops, whether it's a type, what is the type of this particular, you can just see the attribute data that has been linked to this particular. So like this, wherever you are seeing all the buildings, the information is attached to it, right? So the type, whether commercial complex or number of floors, how many building and all this, shops, whatever. So this is one aspect where you can just link this. Yeah, then you can just see the flood maps, like contour information. You can just see the built up area, whatever the pink color, you can just see all the built up area in Cyberabad, and the water bodies. You can just see the original layers and the shrinkage in water bodies. Also, you can just see over the period of time if you have different satellite data sets. Say, for example, this data is of 2018 or sometime, and if I have 2010, if I have 1990 or 70s or 80s, 90s, and whatever, so decadally over the period, how this particular water body, if you just take it into consideration, this particular water body, whether it has been encroached upon, whether shrinked, or what happened to that. If it is encroached upon, whether it has been converted into an agriculture area, whether it has been converted into a green area, the kind of avenue or whatever the urban landscape, or whether it's been constructed, I mean, converted into a commercial area. So that kind of land conversions can be studied, right? So the flood map also you can see, and eco-sensitive zones in the buffer area. So buffer, I said, like buffer is we call generally a area of influence, like, so say for example, a road is passing through here. You can just see this is the road you have. What is the impact of traffic, right? Peak volume or whatever we call it. The nearest biosensitive or eco-sensitive park is here. You have flora, fauna and animals and all that. So what is the impact of this particular road peak volume on this particular park, right? With reference to air pollution, you can say, with reference to noise pollution, you can say, is there any threat to the animals in this particular area, the peak volume? So, if so, yes, if you say there is an impact, then is it going to be within 100 meters? The impact noise level, say for example, peak traffic, 24 hours traffic being, if you assume this as a national highway, so assume that 24 hours you will have peak volume. So 24 hours there will be a noise pollution and there will be a impact on the animals here. So is it only within 100 meters or a 50 meter or a 200 meters, the impact, noise levels? So that kind of buffer analysis also you can do, right? So these are the geomorphology you can just see for this Cyberabad area. And preservation of water bodies based on the NDW, we call it, that is nothing but the normalized differential water body index, water index we call it. So 2000 to 2019, if you see, right, you can just see the changes like individual polygons. If you see this particular water body and there is a shrinkage or increase or whatever, see, you can see this particular bodies and all this. So this kind of change analysis you can do. So what will be the disturbance that has occurred and how best you can minimize, like whether if any facility is there, you want to restore this, you must have read in the newspapers also lake restoration projects, right? So that can be addressed using this. So this is vegetation index map, we call it. So the intensity of green cover, like it shows you are more the positive value. See here, high value 0.8, it is showing, whereas here it is giving as 0.63. So that means there is a shrinkage of vegetative cover or a vegetation or a tree cover. So that can be attributed and this. So the landscape map, you can just see the green spaces, open spaces and all. So the total area statistics we have given in this, and the percentage of open area is 0.46% and the percentage of open area to that of the landscape is 3.63. Right. So in environmentally degraded areas, you can just see the degraded areas also here. And carriageway and service roads having shade from tree cover. See, along this uh, Cyberabad area, tree cover is there along the corridors, the pavements and all that, whether that particular tree cover is there. So if you see the area that is opposite to that Western hotel and all that, where Cyberabad, Cyber City and all that, you have along the pavements you have green cover. So that also we have covered in this particular study to assess the microclimatic conditions with reference to arriving at urban heat island. So your government of Telangana has initiated this Haritaharam program. So that aspect also we can cover under this. So cool pavements, the concrete or whatever, and here also shade from the tree cover you can see. The roof area covered with vegetation and high reflective roofing material also in the buildings. You can know the exteriors and the interiors. The exteriors of this, whether HRI reflective index is more or not, or the interiors and all that. That also you can see. So transit-oriented development, integrated land use, the road network density, you can just see the road surface and the slope aspect. So these are the certified projects we have in the individual projects, whatever you have, your ICICI Bank and Manikonda area somewhere. That so these are all the some of the platinum rated. You can just see the colors, gold and the silver buildings, individual buildings you can have. Right? So transports in the city, connectivity, how it is, metro, rail, bus route, rail terminals, bus parking. I mean the bus, public transport. So this is the water harvesting. You can just see the rainwater harvesting part. And this is another one is lighting efficiency. You can map your LED street, whether the street poles, whether you have LED lighting system or the normal traditional. So that also you can see, right? So the photovoltaic system. See here, actually the multi-patch shadow we call it. See when I'm showing this, like you can just see individual buildings, like See, everybody, domestic applications, you have PV, photovoltaic, solar power, and all that you can have. And the efficiency, like a commercial space, see, you in the high-tech city area, individual buildings are having with, say, a lakh square meters of building rooftop is available. So that can be put to use, right, for this particular PV solar. So thereby making the building as net zero in terms of energy aspect. So not that all the buildings can have PV, the rooftop. Basically, what I'm saying is the shadow. So the adjacent buildings, the shadow and all that may fall on the present building, the under consideration for PV. So you need to look into those aspects. So that also from remote sensing you can have. Is it clear? Like, hope I'm not boring. That the applications. Any participant, if you have any doubt, you can just stop me in between also, because we have done number of projects, works, and also I don't know where to curtail and how to curtail also. That is one of the, I mean, what to say, the negative part of it maybe. So I feel like this kind of urban planning, I mean, the aspects which I have covered will certainly help all of you as architecture in defining, or rather in giving different plans, like, right, for the sustainable development. Right. So one example which I was telling you, see, water bodies, like, see, some of the buildings, like, we have some litigations also, some public interest litigations are there. See, as an architecture, right, as a professional, you are handling, how best, like, you can go with handling a stormwater drainage, like, right? So how do you define as an architecture? You may be suggesting a builder or a proponent saying that you leave a 1 meter buffer this side and that side and construct the building, or you strengthen the retention wall or the whatever the seepage or the whatever and go with some kind of, so your stilt or whatever the basement parking areas and all those things, you are giving as a planner, right, as a architectural or as a designer and all that. Say, for example, if you see this particular imagery, you are having some kind of drainage density you have. How best you can handle that, right? That is what I'm trying to convince you with the technology. So instead of the aesthetics, like, you don't have to disturb the natural drainage you have. See, nobody can alter like natural drainage at one point of time unless you divert all the channels and the inundation, isn't it? So how best you can give a plan to your own client, suggesting them to leave a 2 meter buffer, make that particular, if any stream is passing in their area, see, huge development is coming up in that particular new happening area of our Hyderabad, where some villas or residential areas and some 10 hectares of land or some kind of thing, dwelling units, almost hundreds, a few hundreds are coming up. So if any drainage is passing, if any stormwater drainage is passing through their area, as a planner or as an architectural profession, how best you can define, like, making it aesthetically, making it eco-sensitive area, make that particular stream, let the proponent leave 2 meters this side or 3 meter, whatever the defined definitions are, the guidelines you have, make that particular bit of piece more aesthetic and more eco-sensitive area, right? So that can be taken. That is the essence of me covering all this green city. Another project which we have done is in village level planning also. You can just see, yeah, this. So the how best you can do in rural aspects also, how best you can improve the amenities in the rural area also you can cover. This is the land use land cover map and the database which we have collected. So we have collected around 34 layers of information we have generated. So right from the villagers having a bank card account, or a Aadhaar card, or a phone, or whatever, gas connection, all that. Like you can just see the roof type also, you can see the sheet, who owners, ownership, right? What is he, whether it's he's a farmer or a laborer or whatever, like you can see, and his literacy, whether the number of floors you have, temporary, all this information we have, category wise also, bank account, all this we have generated and we have linked to that. So when you see this Arapalli, this is in Hasanpatti Mandal of Warangal district. So this, you all must be knowing about number of schemes under ministry, Government of India. Earlier we had JNNU project, RAY project, Rajiv Awas Yojana, where slum eradication. Then we have this Swachh Bharat scheme, right? So all these Government of India projects or the state government projects, how best you can use the technology for arriving at a conclusion whether they are well placed in the system or not, right? So that is the basic essence of this particular project which we have carried out. Ujala scheme, the gas connections and all that. Swachh Bharat, under which the public toilets or the community toilets or the private toilets, whether they have constructed or not. So everything you can just see on this particular map. So as a policy maker, I don't have to go and see, physically verify whether a particular person who had claimed 75% of construction cost, like if say 10,000 is for a single toilet, almost 70% is borne by the government and 30% by the individual. So 3,000 I'll pay and 7,000 from the government I'll get. So whether this 7,000 has been utilized properly or not, how will a collector will know? How will a minister will know? Panchayat Raj minister. How will a state government or the central will know? So that with the click of a button, I'll just see whether it has been properly placed or not. Right. So sanitation map, you can just see. And then these are the two we have done for 10 villages in Warangal district. So some of the areas you can just see whether they have a toilet or not. Also, these are the areas, right? Category map. So the best essence of the technology is here is all the red dots say there is a no sanitation facility, in the sense there is no toilet, right? All the green blocks say there is a private or a public toilet, whatever the within the reach. As we have UN Habitat and Settlement guidelines, we have done this, right? So wherever red dots are there, the GIS will enable us. If you think you are as a if you are an administration as a collector, you need to utilize your resources. So this red dot you can see, or this red dot. So as a collector or administrator of a municipal or urban or whatever, you want to construct a community toilet and a public toilet or whatever, CTPT we call it, right? Which area is suitable for you, right? That is one aspect we need to consider. So as a, see, this is only map we have generated. Database is linked to our individual polygon or individual houses, but this map should be able to give a decision for going which area is suitable for community toilet or a public toilet. That is the outcome of this particular map. So accessibility, right? Approachability, like I cannot just construct a, see here only one single block or a single red dot is here. So I don't want to construct a public toilet or a community toilet here, right? But the dependency, the number of people whom you are going to target, if this is in this area, you concentrate on this particular area, like going for a construction of this. So that is the benefit of your GIS and the geospatial technology. So category, the caste, OBC or socially privileged or people, like how they are. So we have some of the schemes specially meant for the deserving people, whether they are well placed or not. That also you can see. So this is the overall income levels. Also you can see annual income levels. Uh, right? So this is what we have done, and we have others also, gas connections, a number of data, 34 parameters we have taken up. So all the maps you have, and due to paucity of time, I may not be able to show you all that. So the other example which we have done is land consumption versus your population growth. Also, we have taken for the same Cyberbath area. So this is the flow chart we have. So you can just see the say Sherlingampalli municipality, the land use map of 2012. You can see 2016. You can see, and 19. This is the area distribution of table showing you the changes, like water body 2.19, and whatever the square kilometers you have in 2012 has shrunk to, has come down to 1.94. So what happened to that percentage change? Whether it has gone into built up cropland, fallow land, or whatever, right? It cannot just vanish, right? Or the built up land has increased from 12.62 to 24. Almost it has doubled, right? The square kilometers, it has doubled built up area. You cannot just bring down from somewhere else and add to it, right? So other aspects, the cropland might have contributed to built up land, water body might have contributed to the built up land, others like forest plantation. So that kind of change detection also we can do. So this is what the change percentage, water body, and how it has been contributed to the other areas, overall change percentage. So this is one thing like we can do. Uh, the other one is this was a very old project which we have done for the Rajahmundry urban area satellite data, Rajahmundry municipality. So I'll just show you the. This is the Iconos data is nothing but 1 meter resolution you have. For every 1 meter, you can map individual building or a tree or whatever. So two objects should be spaced at a 1 meter distance, right? So digitized buildings, you can just see here all the buildings. So map on 1:10,000 scale, you can see the contours, flood information, so elevation, flood impacts. So similar kind of work you can also extend to any of the urban areas also. So slums prone to flood in that particular area, you can just develop. Then the water supply locations through water tankers. So when there is no protected water distribution system, generally the municipalities encourage supplying through water tankers. So that also you can just map it. Then this is having elementary schools in education system. Uh, the primary schools, all the things like number of database which we have collected have been mapped. These are the primary schools you have, wards with primary schools, wards without primary school also you can see. And again the distance from 300 meters from slums. See why we are telling the distance here is as per the UNICEF guidelines and the global guidelines, elementary school or a primary school or a middle school or a college and etc. are to be defined with a distance, spatial distance, like say half a kilometer or 1 kilometer or whatever. So because the preschool children or the primary school children cannot walk or cannot commute for kilometers. So that is the idea of we mapping this kind of preschool to colleges also. We have mapped primary schools within 200-meter distance, right? And again, the liquor shops within a distance of 100 meters from educational institutes. So generally, liquor shops and this kind of activity should not be within a temple place, within the what is called schools or the hospital area, etc. So we have some guidelines. So that also we have been mapped on this. So hospitals we have mapped accessibility, the connectivity where the hospital is, super specialty hospitals, medical shops, and blood bank also we have done analysis of hospitals. So you can just see the spreading like only here, like. So if you want to develop this municipality or urban or whatever the area, providing good facilities in terms of medical and health, which part of the area you need to concentrate. So here hardly you have anything like. So these are the areas, but you don't have to concentrate again on this only, strengthening this infrastructure or whatever, right? So these are the slums in Rajahmundry urban area. You can just see the slum-wise population also we have done, right? Ward-wise distribution, health centers, and this is one of the other one coming to the slums only. Uh, Typology map showing the household size, household. It is in Banjara, just adjacent to the Apollo Hospital, way back. So the income levels showing the typology of the house, tile roofed house or RCC house or the thatched house or whatever you can just map. Then water tap range, public water supply, tap range in the that particular slum area. Right? You can just see the next if you want to have a protected distribution supply, where exactly you want to concentrate here or here, this corner and all that you can come to a decision. Right? Uh, yeah. So this is what I want to convey, based on our experience, based on our projects which we have executed, uh, spatial planning, land use management with geospatial technology coupled will definitely lead to the sustainable development. And India is a signatory in achieving or as for sustainable development goals 2030, where infrastructure, energy, water, land use, uh, land on earth, these are all the sustainable development goals we have. So to achieve the goals as a signatory, the government of India, the best and the available tool we have today is geospatial technology. Uh, this is what I have to say, and thank you for giving this opportunity to the principal SBAC and Raja Reddy sir and all the other for listening patiently. Thank you very much. Uh, Over to you. Thank you.
Thank you so much. We have a few questions from the participants, which we would like to ask you, ma'am. Just give us
Yeah,
a minute. Yes, ma'am.
yeah, please, please.
Yes.
All the participants are faculty, right? It's a FDP program.
Yes, ma'am. Ma'am.
Yeah,
Shalini, ma'am will just ask the questions, ma'am.
yeah.
Yes, ma'am.
Good afternoon, ma'am.
Good afternoon.
We would like to have a few questions which the participants have put it in the chat box. I hope you can hear me.
Yeah, yeah.
Ma'am, the first question: how far will urban land use planning get affected due to impact of pandemic? Will these eventually become part of planning in near future, like what we are thinking for architectural space planning?
Ma'am, can you just, some echo is coming. Can you just repeat the question? I suppose, if I'm correct, during the pandemic, will there be any change in land use? Is it
Yes, ma'am.
correct?
Yes, ma'am. Again, if you want, I'll repeat it again, ma'am.
Yeah.
How far will urban land use planning get affected due to impact of pandemic? Will these eventualities become part of planning in near future, like what we are thinking for architectural space planning?
Okay. Yeah. See, in the first and slide, if you remember, I had shown the movement of population, global trend, and national trend also urbanization trends. So 2040 or 50, you can remember there is a decline in urban migration. Like there will be, that is what the projections they have given. So that is one aspect. And in with reference to the pandemic, the speculation is like there will not be much impact the pandemic. It's only a phased manner or in the time period. Like we'll have say a couple of years we'll have this impact, but again definitely we'll be having the urban as the destination. So there's only a short-lived impact. I don't think it'll have any long term. Yeah.
Okay, ma'am, our next question. How efficient is GIS in mapping changes on land immediately after any natural calamities like earthquakes?
Yeah, that is the best and the best tool I can say, especially in any of the natural disasters, or rather in the sense preparedness. Like, see, initially disasters, see, your monitoring and all, first how well you are prepared. Like, so the technologies which I have discussed till now, right from your the remote sensing, we have exclusive satellites which monitor our weather monitoring satellites we have, which give us climate changes or a flood forecasting and all this data. So that makes us prepared, right? And the Kedarnath incident few years back, right? That's a natural disaster we had, the calamity or whatever. So that has been attended by the GIS only. So the crowdsourcing we call it, where the individual people have uploaded their database, complete rows or the areas that have been mapped. That is one aspect where disasters have been addressed. Case studies also, number of case studies, and earthquakes also. Yes, emergency risk management or preparedness, where whatever you are talking, if you understand, GIS is one thing which enables us in decision making process, right? I've shown you a couple of images before, especially in Rajahmundry case or in the Warangal case study. I have shown you the road connectivity, and I had also given you the hospitals, also given you the maps, or the blood bank or whatever the medical shops. If any natural disaster or if any man-made disaster, say imagine a rail accident occurs, right? The casualties, how you are going to rescue them, how you are going to address that particular as a planner or as an administrator. The first and the foremost, are you sending all the people, the who are there in any rail accident, to all the super specialty hospitals which are centered around, or you will take a map, then you just address that with reference to, see, I'll just show you one thing. uh, She best is like whatever you have this particular maps or whatever slum wise you have, or any fire accident occurs, or see hospitals you have. If any rail, imagine there is a railway network going on here, and how best you are going to. So severely injured or critical or whatever you have, you where exactly. Some people may have only minor injuries. For them, you don't have to carry them to this particular super specialty area. A primary healthcare center here will be sufficient enough. So immediate urgency or need whom we are going to address. So in any disaster, whether it's a earthquake or a man-made disaster, rail incident, chemical or whatever, like recent in Vizag also we had some chemical accident, right? So that kind of, if people are affected, the connectivity, you have road connectivity, you have road connectivity, rail, road and accessibility, everything you have on a single click, right? If you are an administrator, as a collector, immediately I'll just see on the I'll be getting the alerts. Chalo, let's have, I mean, let's see 100 people are severely injured, critical, so let them bring here. Only few couple of hundreds are here, like which have minor injuries. And also specialization, here the cardiac or orthopedic or whatever the database you have. If I click, this is a 100-bed hospital with super specialty doctors, with only RMP doctors or only a medical lab assistants, and all that database is included in this. So I'll send a person to here who has multiple injuries, multiple bone fracture, but there is no doctor addressing the orthopedic issues. He's a cardiologist. What is the use of sending those 10 people to this particular hospital instead of a hospital here who has a bone, or orthopedic specialization? So that is the kind of GIS you can have in terms of execution. Uh, for that matter, any kind of activity. So as a pride, you can be just say GIS is one thing where we cannot enter, which is not related to space and time. Right? Only field which we cannot address is which are not related to space and time. But there's nothing on the that is not related to space and time. That is the pride we have giving the solutions using GIS. Thank you.
Ma'am, can you
No
hear
problem.
me
No
now?
issue. No issue. Yeah.
Can you hear me, ma'am?
Yeah. Yeah.
GIS can be used to detect violations and encroachment. Why we are not being able to implement it? By having monitoring station instead of calling for building regulation schemes.
See,
Ma'am,
one
was
thing
I
is,
clear?
yeah, yeah, yeah. See, you have system is established, policies are made, everything is in line with sustainable management or whatever. It is only individual's responsibility, I feel, whether you are meeting the standards or not. So it is not the tool or the technology which can give you the see. Nobody can police. See, all the time you cannot police around. Policing job you cannot. So that's all individual's responsibility. Yeah, why GIS cannot be handled means the present scenario, what the latest technology I said, UAV and drone, right? The GHMC, if I'm correct, GHMC is planning to take map the entire few of the areas for revenue collection, right? In the sense, revenue collection in the sense taxing. See, I have some 10 floors building, but I pay municipal tax only for 5 floors or 7 floors. So this particular 3 floors, the GHMC commissioner, he cannot monitor some couple of thousands of buildings all the day and do the job, or nor the GHMC officials, right? As an individual, my moral responsibility is to pay the tax for the 10 floors, but which I don't do. Now the commissioner or the GHMC is thinking to employ this particular technology, high resolution satellite data or the drone to map the building so that the additional floors. See, GHMC has given a permission to construct only 7 floors, but you have come out with a penthouse or something, where architectural people are involved in it in defining those areas also, a penthouse or something landscaping or whatever you call it, open space, something, right? So the next 3 levels or the 3 floors which are unauthorized can be sensed by the technology or the data, remote sensing data. And we can definitely give that kind of information to the GHMC. That is, see, whether we are able to address the issue or not is the point of uh, consideration to us. Whether they have implemented, whether they have collected the revenue or taxing, etc., is not our job. So our limitation is whether we can address or not. Definitely we can address. Thank you.
Ma'am, our next question. Volunteered geographic information is a good concept which involves public participant participant and GIS tools to lay a bottom-up approach in urban planning process or in urban management. According to you, what could be major challenges to Indian cities faced with huge population densities in adapting GIS platform for public participation in urban planning scenario?
Yeah, personally, I feel there is no limitation. See, we have the best is crowdsourcing, the one of the best tool we have. As an individual, you also can generate your own data and upload on web enabling GIS softwares and visualize how your city is going to be or how your neighborhood looks like. So that kind of crowdsourcing information also you can have, right? So upcoming cities like recently the Jaipur or some city has been city itself, if I'm correct, Jaipur or Bhopal, I don't remember exactly, has been rated as a green IGBC city only. So it all depends. Like you can use the technology, and certainly there will not be any limitations. Individually, your own neighborhood, you just take your own smartphone. You have some of the apps available on Google Play Store. You download, just go around your phone. I mean, with your phone, just go around your house or five, six houses around your neighborhood, within your neighborhood. Just map those things. Yeah, accuracy may not be. If I say some 10 feet or 20 feet variations may be there, but you can map that. In the similar way, you can ask your students to map their own neighborhood and see how the data is building up, right? Accuracy we can take later on when it comes to your execution level, right? But for the implementation, just for the understanding of the technology, you can do with your smartphone also. Yeah, thank you.
Ma'am, our next question. Um, Excellent, extensive work you are doing, ma'am. The simplified presentation could also help us to understand which site could all this detailed data be accessed, especially with reference to Hyderabad.
Yeah, with reference to Hyderabad, see the National Urban Information System, some of the government sites are there, and NRSC, National Remote Sensing Center, you have, wherein you can get freely available data for your Hyderabad and all. And we have in under Ministry Department of Science and Technology, if you just log in, NRDMS, we have National Natural Resources Data Management System, under which we have done this Village Information System project. So some of the maps and some of the projects are available on the website, and some are on the custodian of the NRSC site, and you can get on the ministry sites also. Urban National Urban Information System in UIS.
Okay, ma'am. Ma'am, this is all the question
Yeah,
we have
thank
today.
you.
Um, Now, ma'am, now we would like to thank Dr. Vijay Lakshmi ma'am for her amazing lecture and great presentation. This session was very informative for giving us knowledge to understand spatial urban planning and land use planning, which contributes to sustainable land management. With the help of varied case studies, ma'am, thank you for the overview and concept of geospatial technologies and spatial way of decision making, preparing us for the future and giving us insight about the techniques. Also, sharing with us the excellent data and information which will definitely help architects and urban planners. Ma'am, we are thankful to have you here. Thank you, ma'am.
Thank you very much. Yeah, thank you.
We shall break for lunch now and we shall join back by 2:20 participants. Our session begins at 2:30 sharp. And we have Mr. B.V. Subbarao former advisor, Center for Climate Change and for Engineering Staff, College of India, presenting on spatial urban planning and land management, considering the future pandemics as a topic in the evening session. So we may break for now, or you can just be logged in also if it's convenient, or you can join back the session at 2:20. Thank you.